The last thing we talked about in chapter 7 was solving logarithmic equations. So here you can see I have the equation log base 3 of 4x plus 1 equals log base 3 of 2x plus 7. Well, since I have logs with the same bases on both sides, the pieces that must be equivalent are this 4x plus 1 piece and this 2x plus 7 piece. So what I'm going to do is I'm going to think about, okay, that means that 4x plus 1 equals 2x plus 7. Little equation here. Let's see what this gives me. Looks like x equals 3. If I check my work, if I plug in 3, I would get 4 times 3 is 12, 13, so log base 3 of 13. That's 6. 2 times 3 is 6, plus 7, that's 13. Yep, log base 3 of 13 equals log base 3 of 13. Cool, 3. Here I have something a little bit different. I have log base 2 of y plus 4 plus log base 2 of y equals 5. So you can see that I have two different logarithmic expressions on one side of the equal sign, and then I have it equal to a constant. That looks quite a bit different than the last problem that we had. So let me think about this for a second. Well, what if I could at least condense down the left-hand side? Well, I could do that using my properties of logarithms. So I know that with addition, I could use my quotient property, and I could rewrite y plus 4 and y using multiplication. So let's start there. So I'm going to get, log base 2 of y plus 4 times y equals 5. Okay, well, y plus 4 times y, I can do that. That's going to be log base 2 of y squared plus 4y equals 5. Okay. Well, I'm getting closer. I know that I can think of log base 2 of y squared plus 4y equals 5 as 2 to the 5th power equals y squared plus 4y. So I can rewrite in exponential form, and I would have 2 to the 5th power equals y squared plus 4y. 2 to the 5th is 32. Okay, subtract 32 from both sides. I get 0 equals y squared plus 4y minus 32. Okay, and now I have a quadratic, so I'm going to factor. I get 0 equals y, plus 8 times y minus 4. So that tells me that y plus 8 equals 0. So if I subtract 8 from both sides, we get y equals negative 8. And then also y minus 4 equals 0 using my zero product property. So I get y equals 4. I probably just want to, make sure everything works out. So let's see. If I plug in negative 8, I would get negative 8 plus 4. Negative 8 plus 4 is negative 4. I don't know if you try this on your calculator, but if you plug in log base 2 of negative 4, you're going to get an error. So this guy, -8, is an extraneous solution. 4 will work though. I can plug in 4, I get log base 2 of 4 plus 4 plus log base 2 of 4 equals 5. And that's true. Okay. Let's continue with one last example. Here I have solved the equation log base 3 of 2x minus 1 equals 2. Well, this is going to use a similar idea to the one I was thinking about before. I have log base 3 of 2x minus 1, and I have it equal to an integer. I don't have a logarithmic expression equal to another logarithmic expression. So what I can do is I can think of this in exponential form. And when I think of it in exponential form, I think 3 squared equals 2x minus 1. Well, 3 squared is 9. Add 1 to both sides. I get 10 equals 2x. Divide both sides by 2. And I can see that x equals 5. Voila!